In this video, we will answer a short answer question or fill in the blank as an exercises for chapter 6, 7, and 8. In fill in the blank, we will write only the correct answer even though we will write few solutions for your information. So in this question, if f of x is equal to a, where a is an element of real numbers, meaning a is a constant function, then the difference quotient where h is not equal to 0 is blank. So here, since we know that a is a constant function, so it means when we get the difference quotient, this f of x plus h is a, and f of x is also a because it's a constant function. So the output is always a. And we know that a minus a is 0. 0 divided by h is equal to 0. So that is the answer for this question. And then alternatively, we can have another solution in finding this, since we know that this difference quotient is also equal to the slope. Then we can write this given as mx plus b. So to write this as mx plus b, so this is equal to 0x plus a. 0x plus a is simply equal to a. And if you will compare to mx plus b, meaning m is 0. So that's why the slope is 0 or the difference quotient is 0. So that is another way instead of using this formula. So let us try the next question. The next question is if f of x is equal to negative 4x plus 2, find the difference quotient again. So here we can follow the solution that we have shown in relation to the slope because this is equation of the line, or this is a linear function. So what we can do is try to compare this f of x, which is negative 4x plus 2, compare it to mx plus b. And we can see that m is the coefficient of x, which is negative 4. So it means the difference quotient is negative 4 because that is the slope. Or alternative solution is you can try this formula in solving that. The next question is finding the domain of the function with log base 3 of x squared plus 4. So in finding the domain, we will apply the domain of a logarithmic function. And we know that the domain of logarithmic function, this expression here, which is x squared plus 4, must be greater than 0. It must be positive. And we can see here, if we move 4 on the other side, we know that in this x squared, when you squared any number here, whether it's 0, whether positive 1 or a negative 1, if you will square that, it will always give us a positive number. And the left side is always greater than negative 4 because this is positive. Positive is always greater than negative 4. So it means the x values here are all real numbers. So it means to say, in this log function, even you put a positive 0, even you put a 0, positive number or negative number, it will always give you a positive. So meaning it's all real numbers. And then for the next question, the domain of the function 1 over 2 to the x minus 4 is. So in finding the domain, we will apply the domain of f over g since this is a fraction. And since this exponential expression is in the denominator, so this must not be equal to 0. So we set that 2x minus 4 is not equal to 0, and let's solve for x. So by moving negative 4 on the other side and then changing this 4 as 2 squared, so these two expressions are equal only if the powers are equal. So we just equate the powers. So it means x is not equal to 2. So the domain of this function is all real numbers except this value of x, which is 2. Now, the next question is, given the rational function x squared plus 1 divided by x squared plus 2x plus 1, then find the following. So in this function, let us factor the numerator and denominator. Since the numerator cannot be factored because this is a prime, and then the denominator can be factored as x plus 1 times another x plus 1. So here, in finding for the x-intercept, in this rational function, the x-intercept appeared as the zeros of the numerator. So take note that when you get the zeros of the numerator, they are the x-intercepts. Since we cannot find the zero here because this can never be zero, since we cannot factor and it is a prime, then there is no x-intercept. And then to find for the y-intercept, we set x equal to 0, and then when we put x equal to 0, this term, and this term are all zeros, so we have y equal to 1. So that is the y-intercept, y equal to 1 or 0, 1. Next is, let us find for horizontal asymptote. Horizontal asymptote is determined from the degree of the numerator and denominator. So if the degree of the numerator and denominator is equal, then the horizontal asymptote is y equal to the coefficients of numerator and denominator, which is 1 over 1. So the horizontal asymptote is y equal to 1. And then for the vertical asymptote is identified or determined from the zeros of the denominator, because we know that the zeros of the denominator is equal to the vertical asymptote. So the zeros here is x equal to -1. So there's only one vertical asymptote since they are the same factors. And then for the last one, getting the whole, we know that there is a whole in the rational function if there's a common factor in numerator and denominator. Since there's no common between them, so therefore there is no whole. For the next problem, given the right triangle below, then the value of x in two decimal places is. So here we can see that x is the hypotenuse in this right triangle, and then 14 is the adjacent side of this angle 52 degrees. So we can use, to find for x, we can use the relationship which is adjacent over hypotenuse, which is cosine 52 degrees. And then substituting the values, so we have cosine 52 is equal to 14 over x. And then finding for x, so it's the ratio or the quotient of 14 divided by cosine 52 degrees. Then put this in calculator in degree mode, then you will get 22.74 as the value for x. Then for the next question, given the graph of the function on the right side, then the new function negative of f of negative x plus 2 has the domain and range. So in this given function, so let us apply this transformation. Let's start with this negative in x. So when you say negative in x, so the reflection is about the x-axis, and when you reflect this absolute value or this graph, it will be the same when you reflect on the y. So it will be the same graph. And then next is this negative in the y means a reflection about the x-axis, so this graph will be reflected across the x-axis. And then after that is the transformation is plus 2. So from this graph, so it will move 2 units upward. And then now this is the graph of the new function. So we can now find the range, the domain here, which is from minus infinity to positive infinity. And then the range is from minus infinity up to positive 2, where 2 is included. So these are the answers. The next statement is the reference angle of 610 degrees is. So when you say reference angle, this is an acute angle formed by the terminal side of the angle and the x-axis. So here, since we can see that it's more than 360 degrees, so first let us find the coterminal by subtracting 360 degrees. So we get 250 degrees. Then from this 250 degrees, from here we can find the reference angle. So the reference angle is, since this is more than 180, remove the 180, and then you will get 70 degrees, which is an acute angle. So this is the reference angle for 610 degrees. And then for the next statement, the positive coterminal angle of negative 760 degrees is. So since the angle is a negative, so to find for the coterminal, and what we did here is we added 2 revolution, which is 2 times 360, and we got the sum, which is still a negative angle, which is negative 40 degrees. So continue adding 360 degrees, then you will get 320 degrees. So this is the positive coterminal angle. Now the next question is, classify if the function below is A, 1 to 1 or not, 1 to 1, B, even, odd, or neither. So on the first blank, so we have to identify whether it's a 1 to 1 or not. And then for the second blank, we have to identify whether the function is even, odd, or neither. So if we have a function 2 to the power x, which is an exponential function with the base 2, so we can see here that we can identify if a function is a 1 to 1 when horizontal line test is satisfied. And we can identify whether the function is even if the graph is symmetric with y-axis, and it is an odd when the graph is symmetric with the origin. So since all of these are basic functions, so let us try to sketch the graph of each. Like for example, in 2 to the x, this is an exponential function, an increasing function, because a is greater than 1. So we can see here that it's 1 to 1 using horizontal line tests, and this is not even, not an odd, so it's a neither, because there's no symmetry in the y and no symmetry at the origin. And then for the next function, we have an x squared, which is a parabola opening up. So this is not 1 to 1 using horizontal line tests, but since this is symmetric with respect to y, meaning this is an even function. And then for y equal to 2x, so we can see that it's 1 to 1 using horizontal line test. And then we can see here that it is an add function because symmetric with respect to the origin. And then next is f of x equal to 2. It's a constant function. And we can see here that using horizontal line test, it will intersect at infinitely many points. So this is not a 1 to 1. And this is symmetric with respect to the y-axis. So this is an even function. Next is an absolute value function, which is this graph. And we can see here that horizontal line test will not satisfy. So this is not 1 to 1. But this is symmetric with respect to y. So this is an even function. Next is the sine function like this, and we can see here that this is not 1 to 1, and the symmetry is in the origin, so that's why this is an odd function. And the next is the cosine function, which is like that, and this is not a 1 to 1 again, but the symmetry is with respect to y, so this is an even function. And then for the log function with base 10, we can see here that log function is a 1 to 1, and there is no symmetry here, so meaning this is neither.